Good morning, class. I welcome you today to our summer lesson 2021-2022. This is Matter Day Secondary School, DDL Akuzu, Representation on Mathematics by Christos. In this our lesson today, we have some specific objectives that we have to talk on. But meanwhile, our main topic here is number base. And this number base, by the end of the class, we are supposed to know what exactly is number base, types of number base, conversion from one base to base 10, conversion of a decimal fraction into one base to base 10, and conversion of a number of one base to another base. What is a number base? Number base is just combinations of digits that a particular system uses in counting. What do I mean by that? Every organization or every system of counting has mixtures of two different numbers. Now let me bring it to everyday life. When we go to our banks, we do withdraw. They put the money in base of 100 pieces, 100 pieces, 100 pieces, 100 pieces. That means 100 digits. That is a base. If you want to collect 10,000 by 100 naira, you get 100 pieces. If you want to collect 10 naira by 1,000, you get 100 pieces. If you want to get 100,000 naira, you get 1,000 by what? 100 pieces. If you want to get 50,000, you get 500 by what? 100 pieces. That is a base. That particular system used that base in doing what? Counting. Don't get me wrong. Number base is quite different from tallying. You know, in tallying, you count and you use one of the digits to bind the rest of the numbers. What do I mean by that? When you come to our locality, for example, when you go to the POS agents to do withdrawal and say you want to withdraw 100,000, you see they will count 99,000 and you use the last 1,000 that will make it 100,000 to bind it. That is tallying. But in a number base, when you go to the bank, they will count 100,000 and they will bring an extra band to band that 100,000 together. That is a base. Another good physical example is our hands. When you bring your left and your right hand, they are in base 10. When you count your phalanges or your fingers, they are 10 of them. When you count them, there are 10 of them. When you bring your two legs together, they are in base 10. There are 10 of them. That is a real example of a number base. A base is any whole number that is greater than 0. 1 is a base, 2 is a base, 3 is a base, and so on and so forth. Even 0 is a base. The most commonly used base is the base 10. In our secondary school, in our primary school, in our pre-kindergarten, they teach us how to count. They first of all teach us how to count from 1 to 5. That is base 5. They will teach us to count 1, 2, 3, 4, 5. When we come to primary 1, they will teach us how to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That is base 10. And when we go ahead, the bases keep increasing. So that is just what we mean by a number base. Now let's go to the types of number base. There are 4 most common types of number base that we mostly use. The decimal number base system, the binary number base system, the octal number base system, the hexal number base system. The decimal base system is base 10. The binary base system is base 2. The octal base system is base 8. and the hexadecimal base system is base 16. Now let's go to the decimal base system, that is the base 10 number system. What is a base 10 number system? Just decimal numbers that has a base of 10 because they are made up of 10 digits. Some other books will call it characters, some other books will call it symbols. When you come to computer or data processing, they will call it that, they will call it digits. Mathematics will call it numbers, and so on and so forth. So base 10 is basically made up from 0 to 9. We don't count 10, we don't have anything like 10. Our digit starts from what? 0 to 9. So the number we call 10 is a number system that we formulate by ourselves. We put 1 and what? 0. That is why in the number basis it's a combination of what? Digits. It might be 2 digits, it might be 3 digits, it might be 4 digits. Now, in base 10 or decimal, we don't see 10. No number there is written as 10. They don't know anything like 10. It's 1 and what? 0. It forms 10. We'll see that when we go to the next type of number base. Now, example of base 10 here, system, you see characteristics is there. We see from 0 to 9. Now, for example here, we have 4,872. You see the place values of the digits. 4 is for thousands, 8 is for hundreds, 7 is for tens, and 2 is for what? 1 value. It's just like our normal 100 tens and units we do in the primary school. You see the 1,000 sides, you see the 100 sides, you see the tens, and you see the units. That is just a base. That is base 10. We are working, we are adding, we are subtracting all in base 10. We are multiplying and dividing all in base 10. Let me shock you. When you go to the filling station to fill your fuel, to fill your tank, or to buy a fuel for your generator, do you know that that dispenser measures your liters in base 10? You even pay in base 10. When you go to ShopRite to buy, you buy most of the things you buy there in base what? 10. So the place values between 1 and a point is what we call a whole number. And after the point, we call them what? Decimals. All those things are in base what? 10. Whether 1.2, whether 1.5, all of them are in base 10. Just that one is a whole number, another one is a decimal what? Fraction. Now let's go to the binary number of systems. That is the base 2. What is the binary number of systems? Where do we apply it mostly? Where do we see it works mostly? Binary number of system here is just a system of counting where we use 2 different symbols. The 2 different symbols are what? Or 2 different digits are what? 0 and 1. Instead of what? 10. We use what? 0 and 1. Where do we apply this binary number system mostly? We apply them mostly when we use our computer systems. You see, our computer systems, our ATM, even our phones, anything we type or anything we write, the computer in his brain see it as 0, 1, 0, 1, 0, 1. Depending on the base, you send that information to that system. But when we are working, we are seeing that I am typing Obi is a boy. But the computer is reading it as zeros and 1, zeros and 1. That is the binary number system. It works with it there. But now, it starts from 0 and 1 before it goes to the different higher word bases. Now, example of binary number system from the chart you can see there. You see how I've converted, the chart is showing us how we've converted decimal numbers to binary numbers. 1 that is in base 10 remain 1 in the binary in base 2. 2 that is in base 10 is 10 in base 2. 3 that is in base 10 is 11 in base 2. And 4 that is in base 10 is 100 in base 2, and so on and so forth. Now let's go to the octal number of system, that is the base 8. Unlike the base 10, the octal is just made up of digits between 0 and 7. That is characters from 0, 1, 2, 3, 4, 5, 6, 7. We don't count the 8th one. Since we started with 0, some of us don't even know that 0 is a digit. They believe that 0 is just nothing. No! When we come to counting, 0 is a digit. When we come to computer language, 0 is a digit. And 0 is the most important digit in computer world. That is in the computer brain. 0 and 1, they are the most important digits. So don't always throw it off or don't flush it down your toilet. So octals are just number-based systems of 8. They use digits from 0 to what? To 7. You see, the chart there shows us conversion from octals to binaries. 0 in octal means 000 in binary. 1 in octal means 001 in binary. 2 in octal means 010 in binary, and so on and so forth. Now let's go to the hexadecimals. What are hexadecimals? Now here is where we have some further explanation, because some things are being added here. Hexadecimals are just a type of number system in which the base values starts from 0 and end to 16, from 0 to 16 digits. But now these digits are not just numbers. Now let us see. The symbols starts from 0, 1, 2, 3, 4, 5, 6, 7, 8, up to what? 9. Because we started with 0, 9 makes it the 10 digits. Now for us to go to 11 now, we don't more use numbers. Numbers ends there. There is no number in the computer language that is 12, that is 11, no. After numbers, the next thing that starts it are what? Letters. So our number 11 is A, our number 12 is B, our number 13 is C, our number 14 is D, and our number 15 is E, and 16 is what? F. We will not over expatiate or over detail the hexadecimal. You see it in your data processing, and that is where it is applied the most. Examples of where they use hexadecimals are, we use them in producing our websites, our color intensity, producers of phones and producers of apps and producers of gadget applications we use online. Most of them apply the use of hexadecimals to define the color intensity of their apps and their websites. So that is where we apply hexadecimals the most. Now summarily, we have the types of number system. We have the binary system, we have the decimal system, we have the octal system, and the hexadecimal system. So what do we say are the number bases? Just combination of digits that a system uses to represent, or a system uses in counting numbers. We say there are 4 types. We have the decimals that starts from 0 to 9, the binaries that are made up of just 2 digits, which is 0 and 1, the octals that are made up of 8 digits, that is from 0 to 7, and the hexadecimals that are made up from 0 to F. Thank you for watching my video. I hope you learned something new. I still remain your humble facilitator, Christos, the mathematics teacher, your mathematics teacher. Welcome and have a beautiful summer.